Take a tour through the fascinating geologic records left behind by the major milestones in Earth's 4.5 billion years. Here, we focus on the events that shape the planet's surface, such as giant impacts and its oxygen-rich atmosphere. Earth forms. It's hard to know when the Earth first formed, because no rocks have survived from the planet's earliest days. While scientists disagree on the details, most researchers think Earth formed by a series of collisions that took place less than 100 million years after the solar system coalesced. More than 10 impacts with other bodies added bulk to our growing planet, according to most models of Earth's formation. By measuring the age of rocks on the Moon and meteorites found on Earth, scientists estimate the Earth consolidated by 4.54 billion years ago. The young planet had established an atmosphere and iron core when, boom, Earth-Moon collision. The final collision in Earth's timeline was with Theia, a rocky planetoid perhaps the size of Mars. This protoplanet sideswiped Earth, leaving our planet mostly intact but destroying itself and blowing away Earth's atmosphere. Theia's vaporized debris condensed into Earth's moon. Some researchers think remnants of the pre-collision Earth still exist deep in Earth's mantle and outer core today. The mantle is the layer between the surface crust and the core. Magma ocean, the force of the moon-forming impact left Earth a churning hot magma blob. The hellish conditions meant Earth resembled Venus for a time, with a hazy, steamy atmosphere. But as the planet cooled, lava became rock, and liquid water started to condense, forming Earth's first ocean. The oldest minerals found on Earth, called zircons, date back to this time, and are 4.4 billion years old, first continents. Today, Earth is completely covered by giant tectonic plates of continental and oceanic crust. But the young Earth's first tectonic plates were much smaller. These protocontinents were recycled volcanic rock that had been remelted or also buried and converted to metamorphic rock. These metamorphic belts often contain rich deposits of gold, silver, copper, and other precious metals. The Earth's new crust grew rapidly, with about 70% of the crust formed by 3 billion years ago, researchers think. The earliest chemical markers of life also appeared with the first continents about 3.8 billion years ago. Breath of life. The first whiffs of oxygen from the evolution of photosynthesis emerged in rocks about 3.5 billion years ago. Photosynthesis was one of after-atmospheric oxygen levels spiked 2.4 billion years ago. Not much happened on Earth for another billion years. Earth was so staid that scientists call this stretch of time the Boring Billion. Things were pretty quiet tectonically, too. The continents were stuck in a supercontinental traffic jam for most of the Boring Billion. Many researchers think there's a link between the lack of tectonic activity and the Boring Billion. Perhaps life needed a kick from drifting continents to drive evolution past photosynthesis toward complex bodies. Supercontinents. The Earth has been covered by giant assemblages of continents, called supercontinents, several times in its past. The best-known supercontinent, Pangaea, was the birthplace of the dinosaurs. But even the Earth's first continents were drawn together into supercontinents multiple times, researchers think. The remnants of ancient mountain belts help researchers fit the continents together into their past patterns, like matching puzzle pieces. Big Chill. The Boring Billion went bye-bye when a big supercontinent ripped apart 750 million years ago, triggering a global chill called the Snowball Earth. This model suggests the planet was a mushy snowball, nearly completely covered with glaciers. The volcanic eruptions and rock weathering that accompanied the supercontinent breakup had trapped carbon dioxide, massively cooling the planet. Geologists have found evidence of glaciers on every continent from this time, even at spots that were at tropical latitudes. Life explodes. The atmosphere's oxygen levels started rising again roughly 650 million years ago, about the time when the first animals appeared. The first hard parts on animals appeared during the Cambrian period, 545 million years ago. While researchers have yet to agree on the reason for this explosion of life, many think a combination of factors spurred this extraordinary jump from single cells to complex creatures. For instance, the spreading continents sent a surge of nutrients into the oceans and opened up new habitats. And an evolutionary arms race set off as animals fought to chow down on each other and protect themselves from predators. Mass extinctions. Earth has been plagued by mass extinctions since the Cambrian period, but the biggest in the fossil record was in the Permian period 252 million years ago. More than 90% of life died in just 60,000 years, researchers think, compared with percent of life during the dinosaur-killing extinction at the end of the Cretaceous period 66 million years ago. However, the primary suspect in the Permian die-off isn't a meteorite impact, but a giant volcanic eruption in Siberia. Scientists think the massive lava flood created toxic greenhouse gas conditions. Chemical elements in old rocks also record mass extinctions due to climate change, such as 450 million years ago, when more than 75% of marine species died during a major ice age.